Okay, this is Northern Oklahoma College Algebra, Math 1513. I'm doing chapter 1.3. This is an example for your assignment, problem number 1. We're talking about quadratic equations and solving them by factoring. And first, let's define a quadratic equation. A quadratic equation is anything that can be written in this form as something squared plus something times an x plus a plain old number, which we call a constant, and it's set equal to 0. If you can write it in that form, it's called a quadratic equation. If you want a simpler definition, maybe not 100% correct, but simpler to understand, it's anything with an x squared in it. Could be something like this: 3x squared plus 4x plus 7 equals 0. Could look like this: 6x squared plus 18x equals 0. Usually what I look for in quadratics is the presence of an x squared. If you see an x squared, you're dealing with a quadratic equation. Now, before we can solve by factoring, we have to understand what the book calls a zero product principle. And what that is simply is if I tell you that two numbers, I'm just calling them x and y, I'm not going to tell you what they are, but I will tell you that if I multiply them, I get 0. Well, if you think about that, what do you know? If you know that I multiply two numbers and I don't know what the numbers are, but I know that it equals 0 when you multiply them, well, you can automatically assume that either the first number is 0 or the second number is 0, because in order to get that 0 there on the end, one of those guys has to be a 0. That makes sense, right? So following that line of logic, if I see something like this, x minus 4 times x plus 5 equals 0, well, here was a times up here, and we decided that that x in front had to be 0, or that y that came after the times dot equals 0. We can use the same kind of idea with that times dot right there. We can say that what comes in front of that dot, the x minus 4, that's got to equal 0, or what comes after that dot, this x minus 5, x plus 5, has to equal 0. Just like we were talking about up here. When x times y equals 0, either the x has to equal 0 or the y has to equal 0. Same thing here. X minus 4 times x plus 5 equals 0. That means either your x minus 4 has to equal 0 or the x plus 5 has to equal 0. And we'll finish talking about that here in a minute. Let's get into a problem. All right, so here's an example for your problem number 1. Now, the book tells us to factor this quadratic equation. Notice that right now we have a plus and a minus. This is basically an addition problem. And when they say factor it, they want you to change it into a multiplication problem. Remember, our multiplication is happening right here between the parentheses. Even though we don't write that multiplication dot, it's there. So we want to change this addition problem to multiplication. Well, your x squared is going to split into x times x. That's pretty easy, and the reason it's easy is there's a coefficient of 1 in front of that x squared. Now, these types of quadratic equations are really easy because we know a little trick to factor them quickly. What we need is, we need two numbers that when you multiply them, I'm going to write this above the negative 10. When you multiply those two numbers, you get this negative 10. But when you add the same two numbers, you get a positive 3. That's the trick. So most people work this problem by starting with the multiply. I think of all the numbers they can multiply to get that negative 10. So I could do negative 1 times 10. Now remember, one of these has to be negative to get a negative 10, so it could also be 1 times negative 10. It could be negative 2 times 5, or it could be positive 2 times negative 5. Now that's all the numbers that I can think of that I can multiply to get negative 10. Now remember the other condition. It needs to add to be a positive 3. So which of these pairs add to be a positive 3? Well, when I add this, I get a 9. That doesn't work. When I add this, I get a negative 9. That doesn't work. When I add this, I get a positive 3 because a negative 2 plus a 5 is a positive 3. That's what I wanted. Okay, so these are the two numbers that I'm going to use. So I'm going to put in a minus 2 and a positive 5. It doesn't matter if the 2 goes in the first one or the second one. Same thing with the 5. All right, now that I know what numbers go in there, I can use that zero product principle that we talked about earlier. Remember where the multiplication is happening. we took an addition and subtraction problem and turned it into a multiplication problem. So that means that what's in front of that multiplication dot equals 0. So x minus 2 equals 0. Or what's behind that multiplication dot equals 0. So or x plus 5 equals 0. That's the principle. And now you just go ahead and finish solving these. You have two separate equations to solve here. So add 2, x equals 2 is one equation, and minus 5, x equals negative 5 is the solution to your other equation. So you can circle these two and call it good, or you can write out x equals 2, comma, that separates your two answers, negative 5. Here's an example for number 3 on your homework. 2x squared plus 5x equals 3. Now remember, on that problem we just did, it equals 0, and that's important. To use the zero product principle, your expression needs to equal 0. So what we need to do is we need that to be a 0. That means that 3 has to go away. So how do I get rid of that 3? Well, just like you get rid of anything, think of it as a positive 3 or a plus 3 and get rid of it. So how do you get rid of a plus 3? You minus 3. We want to make sure we do it to both sides. And now we have 2x squared plus 5x minus 3 equals 0 because these 3's over here canceled out and turned into a 0. Now we have a problem here because in front of our x squared is a number bigger than 1. So we can't use that easy little trick that I showed you on the last problem. This one's a little bit more difficult, and everybody has their own way of factoring these. The important thing is it is going to factor into a parentheses times another parentheses, and it equals 0. That's what we're going for. We just have to figure out what goes in the parentheses. Well, the first part in each two, those two first numbers need to multiply to give us this first term here, the 2. Well, there's really only two numbers that will multiply to give you a 2, and that's 1 and 2. Now don't forget about your x squared. Remember, the x squared splits up nicely into x and x. That part's easy. The x is split up nicely. You have to figure out what multiplies to get you 2. All right, the next thing we have to think about is this number in back and this number in back need to multiply to give us this number in back, the negative 3. And we got some choices there. All right, the only way that you can get a negative 3 from multiplying two numbers is this right here. You can do 1 times negative 3 or negative 1 times 3. Which one do I choose? You know, you really just have to guess. Let's take a guess and see. I'm going to try this first one here and just see how it works out. So I'm going to try putting a, let's see, I'm going to try putting a 3 here and a 1 here. Let's not worry about the signs yet. Okay, don't worry about the signs yet. All right, here's how I do it. Everybody does this a different way, and every professor will teach you a different way, and everybody has a trick. This is my trick. We already have the 2x squared from those two multiplied, and we already have the 3 on the end from those two multiplied. What we're missing is this middle term. So I need to come up with a product that will give us a sum of that positive 5 in the middle. What I'm going to do is I'm going to multiply those two and get a 6x. And I'm going to multiply these two. 1 times 1 is 1x. And I'm going to look at those and I'm going to ask myself, is there any way to get this 5x up here, this positive 5x, from a 6x and a 1x? And if I think about it, there is a way of getting it as long as the 6x is positive and the 1x is negative. Well, how can I make that happen? Remember, I got this 6x from multiplying the 3 and the 2. So I need to make that 3 times 2 wind up being a positive 6x, which means that 3 needs to be positive. And that 1x needs to be negative down here. So I need to make sure that 1x times 1 winds up being a negative. Well, my 1x is already positive there in the front. I really didn't want to put a dot there, so I'm going to try and erase it. Whoa, that took away everything. Let's put it back. Okay, that 1x is already positive in the front, so what I'm going to do is I'm going to put a negative on that one right there. So now by multiplying these two right here, I get a positive 6x, and by multiplying these two right here, I get a negative 1x, which when added together gives me the positive 5x in the middle. I know it sounds complicated, but I know 3 or 4 different methods that other professors use, and this is just as easy or just as difficult as theirs. So this is the way I like to do it. So here's where we stand. We have a 1x plus 3 times 2x minus 1 equals 0. We factored it. Remember, factor means you turned it into multiplication. Now we apply that zero product principle. We say that what's in front of that multiplication dot, the x plus 3, has to equal 0. Or what's behind that multiplication dot, the 2x minus 1, has to equal 0. There's our two possible situations. So I finished solving them. And you guys know how to do the algebra. So I come up with solutions of x equals -3 and x equals 1/2. Here's an example for number 7 on your homework. 5x squared equals -8x. Notice factoring. Before we can factor and apply that zero product principle, it has to equal 0. So I'm going to get rid of one or the other. I like a positive x squared over here. This is a positive 5x squared, so I like that. So what I'm going to eliminate is that -8x over there. These equations are just easier to factor if your x squared is positive. So we leave the 5x squared on the left and we kind of bring the 8x over to join it. We add 8x to both sides. It cancels out, but we need a number over there. So anything minus itself is 0. Those two basically cancel out and leave a 0. And on the left we have 5x squared plus 8x. Remember where we're going here. We're looking for something times something equals 0. That's where we're headed. So we need to change this addition problem into a multiplication problem somehow. Notice this expression only has 2 terms, and sometimes when you have 2 terms, instead of breaking it into 2 parentheses equals 0, sometimes it's easier to look at them and see if they have something in common that we can factor out, or that we can divide each one by. So what I like to tell students is think of 5x squared as 5 times x times x, and think of 8x as 8 times x. Now looking at both of those in their expanded form, what do they both have in common? What do you see that they both have that we can factor out? And I see that we could actually divide each of these by that x they have in common. Now what I'm going to do is I'm going to take that x that they have in common. We're going to call that the greatest common factor. It's the greatest factor they have in common. I'm going to put it in front of a parentheses, and inside the parentheses I'm going to put what's left over after I divide by that x. 5 times x divided by x, well, one of those x's is going to cancel, leaving a 5x inside the parentheses. Here's my plus sign, and 8 times x divided by x, that x is going to cancel, leaving just 8, which makes sense because x times 5x is 5x squared, and x times 8 is 8x, so we're good. Okay, remember what we're looking for. We're looking for that multiplication dot, because either what's in front of it has to equal 0, or what's behind it has to equal 0. Now we solved both of those. Actually, the first one is already solved. X equals 0. We know what x is. The other one, we have to do a little algebra. And I think you guys know the algebra by now. Our second answer would be x equals -8/5.